In this video, we're going to continue with section 3.1, which is about functions. Now, functions have a special notation that we're going to use in this course. Okay, functions are usually denoted with the letters F and G. Sometimes they're lowercase and sometimes they're uppercase. The most popular one is F, lowercase f, followed by lowercase g, and then the uppercase letters come next. Something that we're going to deal with a lot in this course is function notation. Now, function notation looks like this. Sorry, we're back. Okay, function notation looks like this. All right, f with curly braces x, and that is read as f of x. Okay, so you should say when you look at this, f of x. Okay, f is a function of x. Okay, and it's read also, or what it's sort of equal to, is the value of the function f at the specific value of x. Okay, so what does that mean? If I would write f of x is equal to 2x plus 4, okay, and then I say let x equal 2, so I substitute 2 in here for the x, okay, then I would also substitute that 2 over here, okay, and I get f of 2 equals 8. 8. When I'm saying the value of f, okay, this is f, okay, and then I'm evaluating it at a specific value of x, which in this case is 2. So hopefully that makes a little bit of sense. And you can think of a function as sort of a machine, okay, where you input something into that machine and then something comes out of that machine. So in my example above, I had a machine. The machine was 2 times x plus 4. Okay, this is my machine. I input 2. Okay, I input 2. So 2 went in, and then when I did the algebra, which is the machine part, I got 8 on the other side. All right? The function f only accepts values from the domain and only spits out values from the range. Now, this is an important part that we'll discuss later on in the course, okay, and that you'll discuss if you take pre-calculus at length. So, there's an important note that many students get caught up on, okay? The argument inside of the parentheses is just a placeholder. Its specific name that you call it is the argument of the function. Okay, so if I had the function f of x is equal to 2x squared plus 3, okay, many students get caught up with the x being here, and when I change things around, they don't quite make sense. But the x is just a placeholder. Okay, so I could rewrite this like this, f of y, okay, so instead of x I put y here, and what that does to the function is it changes x to y. Okay, so it's just a placeholder. Whatever I put inside the parentheses on the left, that's going to turn whatever was inside before to whatever it is now. So if I substitute in negative x instead of just originally x, then what used to be x turns to negative x. Okay? And maybe x and y are confusing to you. Okay? Even simpler, f of smiley face is equal to 2 times smiley face squared plus 3. Okay? Whatever goes inside the parentheses, okay, this is going to go where whatever used to be inside the parentheses was in the right-hand side. Okay, so the smiley face goes in where the x used to go in. So hopefully that makes sense, okay? And it won't lead to too much confusion. Hopefully it'll actually relieve some confusion. Now, sorry, it's jumping around. Here's a quick example of function notation and how to do function notation. So there are a lot of examples here. I'm not going to do all of them, but I will do a few. Okay, so the first and easiest one is A. Okay, so we'll start with A, and A says I want to evaluate f at 3. Okay, so I replace everything up here. So I have, this is my function. Okay, that's my machine. I input, my input is 3, so everywhere I saw x before, which is here and here, I'm now going to put a 3. 2 times 3 squared minus 3 times 3. Okay, and then I can simplify that. 3 squared is 9, and 9 times 2 is 18. And 3 times 3 is 9, so I have 18 minus 9, which is 9. So my input was 3, and my output is 9. Okay, so 9 is the answer to A. Then I have some sort of mixed stuff here in B. Okay, I have f of x plus f of 3. So this may be, this is maybe where it gets confusing. Okay, here I have f of x. Okay, do I know what f of x is already? Yes. So when I have a symbol in here that's not a number, okay, I'm just going to input that symbol into wherever the placeholder, which was x, was before. So I'm replacing x with x, and lo and behold, I get out what this was originally. So hopefully there aren't too many lines here. Okay. This is f of x. So when I say write f of x, you should just write, f of x plus f of 3. F of x is 2x squared minus 3x, okay, plus f of 3. Now, we already did part A, and so we know f of 3 is 9, so we can just say 2x squared minus 3x plus 9. Okay, final answer. Another one that we can work on, a more challenging one, is part G. Part G. Okay, f of x plus 3. This is where students really get confused, because there's f of x over here, so I just add plus 3 everywhere. Well, sort of, but you need to do it very carefully. What this is saying is that I want you to replace, I have x plus 3 here. That's my input. So wherever there used to be an x, okay, which is here and here, I replace that with the quantity x plus 3. So I get 2 times the quantity x plus 3 squared minus 3 times x plus 3. So you see everywhere there was an x, I replaced it with x plus 3. Okay. So the confusion here is that like I have already an x and then I'm adding 3 to it. But remember, this is just a placeholder. So if that confuses you, just say, all right, I don't want to think of it like this. I wanted to think f of smiley face is 2 times smiley face squared minus 3 times smiley face. Okay? And then I replace all the smiley faces with x plus 3's. So now I'm down here. I need to distribute all of this out. Okay, so I have 2 times x plus 3 times x plus 3. All I've done there is rewritten x plus 3 squared as x plus 3 times x plus 3. Okay, so that's what x plus 3 squared stands for. So I've just elongated it. And then minus 3 times the quantity x plus 3. So when I FOIL all this out, okay, when I do the FOIL steps, I'm going to get x squared plus 3x plus 3x. So that's 6x plus 9, okay, minus the quantity 3x, the negative 3 here goes to both the x and the positive 3. So I have minus 3x minus 9. All right? And when we take the 2 through, we get 2x squared, x squared plus 12x plus 18 minus 3x minus 9. We can then combine like terms, and we get 2x squared plus 9x plus 9. And that is the final answer to this. Okay? So when there's an x involved anywhere, the final answer is not going to be a single number. Okay, it's going to be something involving x. Okay, so those were 3 examples. There are, of course, a lot more here that you can do. Okay, just remember that whatever is here just replaces whatever was in this parentheses all throughout that function. To get some practice on this, I have a your turn. Okay, so I have a function 3 minus t squared, and I want you to evaluate that expression. Okay, evaluate the following expression. So there's 5 things here. I want you to evaluate all 5. Okay, and so that's the your turn for the other your turn for section 3.1.